In this video, we will present the features to generate and verify a temporal logic specification in Apromore. Apromore is an open source and extensible online advanced process analytics platform. Apromore comprises a wide range of capabilities, including process discovery, process model merging, process drift detection, and so on. The newly developed features allow to generate a temporal logic specification representing the common behavior of a set of process model variants. Furthermore, the verification feature allows to formally verify a set of temporal logic specifications on a process model. This can be used, for example, to check whether a process model is compliant with rules or regulations, or whether a new process variant complies with the existing ones. We will subsequently show how each of these features work and what they look like. We have created an account in Apromore and uploaded 3 basic process models, each representing a variant of a room booking system. Although similar in behavior, each of these variants have some distinct features. Let's first have a look at the first variant. An error after book room ends the process, as you can see here. Now let's compare that to the second variant. Here it returns back to view room details instead of ending the process. We will first show how to create a temporal logic specification from a set of process variants. Let's create a specification of 2 variants. We select the process models we want to incorporate and click Extract Variability Specification. We can select which types of temporal logic rules we want to include in the generated specification. For now, let's just select all of them and see what a specification looks like. The specification is represented as a list of temporal logic formulas that can be exported to an XML file to be used later on. The first rule indicates that view list of rooms always occurs directly before view room details, as this is behavior that is common between variant 1 and 2. However, variant 2 has a loop back to view room details in case of an error after book room, but variant 1 has not. This is reflected by the last rule, which states that there exists a path from book a room to view room details, but it does not occur in all cases. That is, it is a possibility only. We can test this generated specification on a third variant to see whether it complies with this specification. Let's download this specification. The third variant differs from the first and second variant, as there is no mechanism to handle the process in case of an error during booking. We select the process variant and click on Verify Compliance. We have the option to either enter directly the formulas to be verified or upload an existing XML file. Let's upload the XML file that we have just generated. The selected model is verified and the verification feature returns a set of specifications highlighted in green if they are true or highlighted in red if they are false. It can be seen that also in variant 3, view list of rooms is always directly followed by view room details. However, variant 3 does not have to loop back from book a room to view room details, so this statement evaluates to false. Note that for understandability purposes, the temporal logic formulas are represented in natural language, such that it is immediately clear which features are compatible with the selected model. Finally, we will show how to evaluate a specification via direct input. For usability purposes, direct input supports the user-specific keywords so that the user does not have to stick to the formal CTL notation. We select again the third variant and click on Verify Compliance. Now we enter a specification for which we want to check whether it holds for the selected model. We want to check whether it is possible to execute view room details after booking room, and in addition we want to check whether register booking in system results in the end of the process. The verification tells us that the first specification evaluates to false, indicating that after book a room, view room details is not possible in a third variant. The second specification evaluates to true, as register booking in system is followed by the end of the process. The new features increase the functionality in Apromore in 2 ways. They add the ability to generate a variability specification of a set of process variants and enable the user to verify whether a process model is compliant with a set of specifications. Furthermore, the capability to represent temporal logic in natural language allows users to perform such a verification without requiring deep technical knowledge.